Section 9.3, circles. Circles are probably going to be the easiest and possibly the funnest of the conic sections to graph. So, as you all hopefully know, the circle is defined as a set of all points in a plane that are equidistant from a fixed point called the center. And that distance, that same distance that's everywhere, is the radius, and that should be a pretty standard definition of a circle. And this is the standard equation of a circle, x minus h. So of course, what's in the parentheses with the x is the x coordinate, and the same with the y, so that's where we get our hk center. And our radius, it's equal to the radius squared. So be aware that that is squared. So there's a picture of our standard good-looking circle, center, that is equidistant in every direction. And specifically, we're going to be graphing these by graphing the center and then moving. The easiest direction would be on the coordinate plane, up, down, left, and right, so that we can move in the same distance. And please do not graph your circles like this, and you are hopefully chuckling that of course this is not a circle, but I do sometimes get circular circles on my papers that look like this. So at least make an attempt. It doesn't have to be perfect, but please make an attempt at making a circle. So let's take a look at graphing one of these. So hopefully you can pick out that my center is 4, -3, the opposite of what's in the parentheses. And then my radius, it's equal to the radius squared, so the square root of 49 is 7. So we graph the center, and we move up, down, left, and right in all directions 7 units, and then we graph our circle. And we're done. Alright, let's look at the next one. Again, we don't really have anything with the x, so hopefully you recognize that that's the same as x minus 0, quantity squared, so my center is at 0, 5. Still equal to my radius squared, so it's equal to the square root of 30, which is approximately 5.5. So we graph the center, 0, 5, and again move in all 4 directions, 5.5 units, and nicely graph my circle. As we move into the last 3 conic sections, ellipses, just the last 2, ellipses and hyperbolas, you're going to become used to seeing the equations equal to 1. And so I just want to make you aware of this, that if you were to see this equation in this form, basically this is meaning that we're going to be moving the square root of that many directions in the x direction and the square root of that many units in the y direction. So since we would be moving the same, it would still be a circle. Alright, so let's move along. We need to write an equation of the circle that passes through a given point and has a center. So let's at least put a little sketch of a plot on what that looks like. And so we've got our center and we've got our point on the circle, so we need to realize that that is the radius. The distance between those two things is the radius. So we could use our equation of a circle to find that distance. We don't necessarily have to go back to the distance formula. The radius is x minus h squared plus y minus k squared. And hopefully, again, you realize that this is coming from the Pythagorean theorem, really. Anyway, we need to find our radius squared. So that means we need to find something to plug in for the other 4 variables that we have. Well, we have the point 5, 1, and we have the point, our center, 3, -6. So we just need to find our r, so let's put in what we know. So we know our center is at 3, -6, that's our h and k. And then that extra point that we have that's on the circle will be my x and my y. So now I just need to solve this, 5 minus 3 squared. And changing my double negatives to positive, I get 7 squared equals my r squared. So I finally get that my r squared is 53. So it doesn't actually ask me to graph it, so I don't really have to find the square root of that to find out what the r is. I just now need to be able to write the equation of my circle. So x minus my center plus y minus my center equals r squared, which is 53. And there's the equation of my circle. In the same manner that we had to be able to complete the square on some of our parabolas on day 2 to be able to graph them, we might need to be able to put this circle into graphable form, and therefore we'd be able to name what the center and the radius are. It isn't very obvious right now what the center and the radius are. So in order to be able to complete the square, we basically need to get our x terms together so we can complete the square on the x's, and our y terms together. And so let's go ahead and do that, and I'm going to leave space in each sets of those parentheses so that I can complete the square on each of them, and recall that this is still equal to 71. So completing the square on the x's, half of -4 is -2, squared is 4. Make sure we keep our equation balanced, so we must add 4 to the other side of the equation. Half of 10 is 5, squared is 25. Again, make sure we keep our equation balanced, so add 25 to the other side. Writing this in completed square form, we get x minus 2 squared plus y plus 5 squared, and adding together all those numbers on the right-hand side, I get that it's equal to 100. And now you can hopefully recognize that my center is at 2, -5, and my radius is the square root of 100, which is 10. I'd like you to try to go ahead and do this next one. I'll get you started. So again, we need to get our x's together and our y's together. And the reason I didn't leave space is because you'll also notice that we have a coefficient in front of the x's and y's. And so I'm going to go ahead and divide everything. Since everything on the left is divisible by 3, I'm just going to divide both sides, don't forget to divide the right, of the equation. And so then I'll get x squared minus 6x, and now I'm going to go ahead and leave a space to complete the square, plus y squared plus 2y, and again leaving a space to complete the square, and that's equal to 2/3. So now I'd like you to go ahead and complete this and name what the center and the radius is, and again we'll look at these tomorrow in class and compare them. And now the last problem. So a business owner wants to buy a property within a 30-mile radius of the airport. She finds a property 10 miles west and 24 miles south of the airport. So is this property within the 30-mile radius that she wants to be? Well, let's go ahead and kind of draw what this means. So since she wants to be within the radius of the airport, let's just put the airport in the center of our coordinate plane. And let's look at our coordinate axis just like a compass rose, north, south, east, and west. And so we can kind of sketch where her property would be, 10 miles west and 24 miles south. And so again, we can look at this distance in terms of the Pythagorean theorem. So my distance squared, the hypotenuse, is 0 minus -10, my x and my y. Changing the double negative, so 10 squared is 100. Changing that double negative, I'll get 576. So d squared is 676 miles. Taking the square root of both sides, because I just want to know what d is, and d is 26. So yes, the property is within the desired distance of the airport. And that concludes our circles. If you have any questions, you know the drill. We'll see you tomorrow.